Moving forward with our schedule for the day, I'd like to introduce our third panel, which is our vehicle certification panel. Our moderator for this panel is Jim Sherman. Jim Sherman joined Vertical Flight Society in May of 2019 as the Society's Director of Strategic Development. He is responsible for setting and executing the Society's strategy for promoting membership development and growth. He is also responsible for supporting the development of the electric vehicle revolution. Prior to DFS, he was the SAE International Events focal point for aerospace and electronic applications, providing leadership in developing new programs for all aerospace sectors. Mr. Sherman's industry experience has been in the area of ground vehicles, power and propulsion systems, and aircraft flight and engine controls. Please join me in welcoming Director Jim Sherman and our vehicle certification.
Everybody get a good lunch in? Yeah. Thanks to Mr. Pierce for his wonderful lunchtime presentation. Appreciate that. It's always good to get NASA's perspective, but it's a hard act to follow when Davis earlier, with Bob Pierce now. Now we got the industry folks and the FAA that's going to take that back in the line. We should be right. So thanks, Zoe, for the introduction. I'm Jim Sherman with the Vertical Flight Society. Most of you probably not heard of me before, but I see a number of familiar faces in the audience. We've been doing this for quite some time, and we have a pretty good panel for you this afternoon. And Joey tells me it's okay for me to go long. So let me go ahead and bring the panelists up. We have John Graber from Workhorse. We have Jantzen from Moog, Sathya from LuftCar, and Michael Romanowski from the FAA. He goes last because he was the last one to accept. Normally when I do these things, everybody comes up and gives these long introductions. I think if you want to learn more about our speakers, you should come talk to them afterwards. So I'm just going to do introductions by name and company. I do have a few slides that I wanted to run through just so those of you that are not familiar with the Vertical Flight Society gets an idea of who we are, and then I'll turn it over to these guys to talk about the great tech and the directions that they're going with their view. So I can get my slides up there. Already. Oh, look at that. So Vertical Flight Society, we've been around since 1943, so over 75 years. We were formed as American Helicopter Society. So some of you probably recognize that. We changed the name about 4 years ago to better reflect those activities that we support, which includes eVTOL. We get involved in a lot of student activities and other kinds of developments, and I'm very lucky to the Buckeye Vertical team, and I was very happy to see they finished third last year. But you do have some tough competition to get beyond there, right? Maryland, Penn State, Michigan. One of the things that we publish is the Vertiflight magazine. If you didn't see it out front, there was 2 copies. They're probably all over. This comes out every other month. We've been covering eVTOL and advanced rotorcraft, advanced vertical flight vehicles, very much in detail for the last 3 years. Here's just a sample of the covers. I do have one that I kept for myself, and I have 2 copies that I kept for Stephanie Morgan. She's here. Everybody's kind of talked this morning about 300, 100. We've cataloged 632 vehicles as of March 16th. So it's been about 3 weeks, so it's probably closer to 650 at this point. It's been coming in 2 to 3 per week in these 5 different categories: vector thrust, lift and cruise, wingless, helos, and hover bikes. On our website, we also capture a number of different articles that we publish. These things are all free on the evtol.news website. You can also click there and subscribe and get our bi-weekly newsletter. But it's a great resource for anyone that's interested in this space and wants to get smart on it and understand what's going on. I'm going to skip over this because it's kind of irrelevant in this crowd. There's the 5 pieces or 6 pieces that we see as part of AAM. Everything from having the shoes delivered all the way to your own personal electric light from Denver, Colorado, to Santa Fe, New Mexico, or further, 600 miles. But so all these different areas, and then as I mentioned, we have some additional resources. We have a YouTube channel, a Vimeo channel, we do, Facebook as well. You just follow those things. Mike Hirschberg posts on Facebook stuff about 10 times a day. What news is going on in the industry. On our YouTube channel, we captured the 100 and how many hours worth of webinars that we did over the past 2 years, which includes some of the familiar faces in the audience here. So if you're interested, just stay on top of it with these things. And then our upcoming events that are related to AAMs. We have our annual forum coming up next month, in conjunction with Cafe. And Jonathan will be on our next panel, the Electric Aircraft Symposium, a couple days before EA Air Adventure in Oshkosh. We'll be back in Ohio at the end of September in Dayton to do an infrastructure workshop. And then our big eVTOL event is in January, and this time it'll be in Mesa, Arizona. So with that, that's all the information. If you got any questions for me, I'll be here in the middle table number 5. I'll be here until the end of the day. But I'm going to go ahead and get us kicked off with our tech presentations. So our first speaker is Justin Jantzen. I already kind of introduced you with Moog. If you come up, do your talk. We'll do the rotating thing like we did this morning, and then hopefully ask a couple of good questions. But please use those cards and send some questions.
Good morning. So as Jim said, my name is Justin Jantzen. I'm with a company called Moog. Before our team's acquisition in 2019, we hadn't heard too much about them. So I'll go out with a little introduction to who is Moog, and it is Moog, not who. And then a little bit about a project, and then we'll get into your presentation. But first, I just want to say thanks for having us out to this event. It's an honor to be a part of this. And for the second round of this event, I think it's pretty neat. So we're proud to be a team out of Cincinnati and just support Ohio and eVTOL and AAM. So great to be part of this. Okay, so Moog, it was founded in 1951. I'm not going to go through all of these, but it's what we want to make clear from kind of this slide deck here is that there's a 70-year history in Moog of high fidelity flight controls, servo actuator valves, being a component manufacturer through the space race into motion controls, and in the last couple of decades into flight control systems. Our team in Cincinnati and in East Aurora, New York, and across the country is the growth and innovation team. So what we're looking to do is take Moog's rich history of high reliability components, systems, flight controls, and spin off new business for us that looks like a few things. My team specifically working on the SureFly eVTOL project, which I guess is one of the 635 projects out there. So we're one of them. We were looking at advanced vehicle solutions. Our team's also looking at electric vehicle solutions, so electrifying aviation. That includes whether that's high voltage battery packs, whether that's battery management systems, or electric propulsion. We're involved there actively being put on some platforms as we speak. And then automation. So automation for us, we're typically looking at helicopters. We're looking at fourth-axis autopilot as we speak, both on the Robinson, EC-145, and some other platforms. But really, that all comes together with advanced vehicle solutions. So when you think of Moog, if you have heard of us, and now you've heard the spiel, we're not a traditional airframe, but we're looking to change that with our team and with our work on the SureFly. And since this is after lunch, I figure I might pep everyone up with a little video of a flight test. This was 3 weeks ago today. We've been flight testing at the Lunken Airfield outside of Cincinnati, for anyone familiar. And disclosure, we do have the benefit of Mr. John Graber as our test pilot, so I'd say that's
Justin, does that mean you're deferring all your question and answers to John?
that's right. Anything about
It does not mean that at all.
I might not complain, but yeah, we'll get it pulled up. But we've been flight testing out of the London airport for, I think it says 2018. And what we have now is an all-electric prototype of our vehicle, and the concept that we're in certification on, that I'll go into here next. So just to give context to when I start to talk about certification, what for our project, what hurdles and challenges we've been seeing, I wanted to go over just a high-level architecture of for us, our eVTOL, right? As you've seen in some of these presentations, and I'm sure you know, going to electric propulsion really opens up the architecture space for what these vehicles look like. There's lifter pushers, there's transitional, and there's some that are a little more simple, like ours, which is just a octocopter or a multi-rotor. We don't have any transitioning surfaces, so just fixed pitch propellers. But for us, that means that we're using a lot of energy. In here all day, you heard about the challenges with lithium battery energy density. That is what it is at the moment. We've got a lot of ways ahead of us. So for us at Moog to get a useful mission out of something like this, that means going hybrid. That means a hybrid electric power plant, and that really enables a useful mission going from minutes to hours of flight. Also leaning on advanced materials and composites. Without that, you don't get a lightweight airframe. You're just back to the same situation with burning more power than you can use for a useful mission. Right now, we're looking at a 2-seat design, but there's a whole space out there for larger concept vehicles. All right, now on to certification. So we have been involved actively with the FAA on what does type certification look like for this vehicle. And I've got a couple of lessons learned there and some thoughts that were along the road of this process. Dr. Romanowski can speak more to this in a little bit, but we'll just share our input from an applicant and working weekly, bi-weekly basis with the FAA engineers on a certification basis. So I'll share some thoughts there. When it comes to certifying these aircraft, there are 4 parts for airframes: 23, 25, 27, 29. 2 of those, 25 and 29, are reserved for transport category, and then you've got 23 and 27 for smaller vehicles like ours. So those are commuter, 2-seat, 4-seat, and a little larger. So when you bring a vehicle like the SureFly to certification, where do you start? Right? It'd be nice to start at 23. Maybe you've heard a little talk about Part 23 earlier. They've, the past few years or maybe a decade on now, Part 23 had the benefit of a rewrite, which went to performance-based requirements. That's great. You can kind of fiddle with the rules to make it fit your platform and the performance that you're looking to get out of your platform and really fit the safety to your design. But really, that's for airplanes, and it just wouldn't be a good fit for something like the SureFly, which is clearly not an airplane. It does not have a wing or the benefit of that to go through Part 23. Then you go to Part 27. Seems like a natural fit. It's an airworthiness standard for normal category rotorcraft, which I'm sure maybe the SureFly is a rotorcraft. But when you start digging in, it really hasn't had the benefit of a rewrite, and it is fairly prescriptive to helicopters. So if you look at this and say, okay, what's the main rotor? What are the auxiliary rotors? You start to get into the weeds there pretty quickly. For us, then, the natural fit at the moment, and Dr. Romanowski will probably talk about a little more future looking here, but is 2117B. It's a little rule in there. 2117A says, okay, whatever's applicable to you, you fit that bucket. If you're an airplane, 23. If you're a helicopter, 27. Go forth and meet the rules. With 2117B, it says, well, if you're a special class, then there are different rules. You can either pick and choose among the parts, 23, 25, 27, 9. as to what makes sense, or you can agree on the rules of the FAA for what makes sense for your platform. For us, and at the moment, without any kind of unifying eVTOL path at the FAA, that's what it looks like for our vehicle. For vehicles with the benefit of a fixed wing, the 23 makes a little more sense, but for us, it's 21. And the FAA is fully behind that approach at the moment. They're looking at a project-by-project basis for kind of meeting the exact design that you have with what they can make work as far as 2117. My last little thought here, rotor versus propeller, is not a issue I thought I would have to work through in my life, but it's not as straightforward as you think. So anybody getting into certification, I would just address that at the forefront of talking with the FAA. 14 CFR 1.1 will not be so where's the last? When we go into specific challenges for our vehicle, right, there's, I think, no certification project is without issue. Right? That's why you work hand in hand with engineers to get to a solution. But for us, there's a few key points that to us are certain challenges with certification at the moment. One is for us, not necessarily some of the other applicants out there who might be able to make a battery work with the benefit of lifting the wing. But for us, we have to rely on a hybrid power plant. Is that part 33? Maybe, not exactly. Is that an APU? Not quite. So it's not a great fit there. And we're working through that at the moment. But probably an engine with special conditions is the closest we have right now. We've had panelists earlier talk about hybrid electric propulsion, how we have more to go there, and really excited to see what's coming forward in the future. Another for us is auto rotation. So traditional helicopter can auto rotate. Those of you aren't familiar, if you're a single engine, you lose main power from your power plant. The pilot can initiate an auto rotation maneuver to get you down safely to the ground using some leftover energy in the rotor disc. Our vehicle cannot do that in any of the mechanisms for it. But we have an equipment level safety for that. So, one of the benefits of this project-by-project basis with the FAA is we can say, hey, we can't auto rotate, but we can do something we think is better. We've got a battery backup, doesn't require pilot skill, doesn't require reaction time to get you into an emergency descent. Is that the equivalent level of safety? We think that's a good approach. We think the FAA agrees, and they're working with us on that. But it's not exactly auto rotation. So rules as written, you got to work around that a little bit. And the next two are pretty closely entwined, and I think it's going to be not specific to our project, but to really any eVTOL out there. Fly-by-wire controls, simplified vehicle operations. Pretty much all these vehicles are looking to take advantage of fly-by-wire. So the pilot moves their stick, whatever that looks like. We're given a platform, and you send signals to the computer, which then actually does the action. There's no direct control like a traditional helicopter. That means that your electrical communication system is much more critical. It also means that pilot feedback and human factors is not a given like it has been in the past. How do you effectively display your control margins to a pilot? How do you let them know if you're relying on battery power, how much gas they have? And simplified vehicle operations means that we're taking a highly skilled pilot, lowering that skill ceiling, and really opening up to people more like operators. So really, for any given eVTOL, advanced air mobility project, what is the role of the pilot? And that's actually a serious question, and again, something that we're working with the FAA on their discussion. The last kind of deep dive I'll do on certification, I'll give some closing thoughts, is lithium battery certifications. As I said, this isn't relevant just to our vehicle, the SureFly being hybrid, we do have batteries and a hybrid power plant, but also others on our team are working strictly on high voltage battery systems, battery management systems. That means we're making a thing called a TSO, TSO C179B, and it's an RTCA component, which is DO311A. That means we got to meet battery thermal runaway containment goals. They are not easy to pass as written, so it's a little bit of a challenge to decide you over temperature your pack, you overcharge your pack, how do you handle just all that energy? These vehicles are going to need a lot of lithium battery energy to have useful missions. So that's a challenge. It's not just our challenge. Everyone in the industry is facing this, but certainly it is a challenge. And then you get to, let's say you get a TSO for your battery pack. Now you have to install it on an airplane. State of charge, state of health. For me, those are equivalent to looking at a traditional airplane and a fuel tank. Your state of charge is, hey, is your fuel tank empty or is it full? Right? Are you at 0% fuel? You got 100%. State of health is how big that fuel tank is. So, unlike a normal fuel tank, which has a fixed size, you hope, right? So you fill it up, you know you've got 2 hours of flight time. You land when you get close to empty, and you're on your way. With batteries, as you cycle them, the capacity decreases. That's just the way it is with big batteries. That's something we have to work on. But that means that if you don't have an accurate way to measure state of health, your pilot could think he or she is looking off with 2 hours of flight time, and they've got an hour and a half. That could severely impact not only your mission, your operation, but also safety. So that's a really critical part of lithium battery certification. Something we're actively working to solve, but is it advancing with vehicles? A couple other things like making revisions and class control battery are other things that we're working on, but they're not clear when you go to TSO, right? That's just the first step to being something. So I've sat here and talked about challenges and certifications for the past 5 minutes. But what I wanted to impress is that for us, they really are just that. They're challenges. They're not roadblocks. They're not dead ends. We're not circling the drain. We bring these challenges to the FAA. They come to us with an open mind. And every single one of these issues and more, probably a couple dozen more I didn't list here, the FAA is actively and enthusiastically working through us on those. So we're happy to find a good partner in the FAA. In the future, if there's more unified path for eVTOL, we'll be more than happy to take advantage of that. But even without that, right now we have a path through certification. And we're really looking forward to getting through that and really showing off the vehicle. So, yeah, thank you.
Well done, Justin. And that's a good way to finish too. You don't, if you want to get your vehicle certified, you don't come up and beat up on the FAA. Okay, so that's a good start for vehicle one. We've got a couple more to go through, and then we'll let Michael come up and tell us why the FAA is being such a good partner this time around. Our next speaker is Sathya from LuftCar. Santh, come on up here and lead us on with your vehicle.
Thank you very much. Great to be here. Let's see if I can play the video. So PDF. So LuftCars are hydrogen powered, dual use, air and pro. I don't know. So LuftCar, first introduce what LuftCar is. So we are based out of Orlando, Florida. Started a year ago. Luft is the only thing German about us. Otherwise, we are pretty much an American company. But it turned out to be a good marketing ploy because Germany's now very interested in our car. It's a true flying car. I call this an electric forklift that can carry the whole vehicle or cargo or anything else from point A to point B, and then achieve true functionality. Door to door, sorry, last mile door to door. So we will be serving the community. It's not just B2B. Okay, thank you. So LuftCar would be a true B2 community type of vehicle. So we will land, take off from point A, land at point B, and the road vehicle can depart and get a cruise services. So let me play the video and take it from there. And LuftCar is going to be hydrogen powered fuel cell vehicle. I originally started LuftCar as a battery vehicle, but within 1 month after having conversations with Department of Energy and some of the mentors and labs, I quickly concluded that it has to be a hydrogen fuel cell car because hydrogen gives you 4 times the energy density compared to batteries. And I personally have fuel cell experience, having done 300 cars for a Ford company back in the day, what was done with that. So I'm very familiar with fuel cell stack, and it was a good conclusion for me to make this into a hydrogen vehicle. The docking mechanism is our concept. That's our IP. The patent is pending approval. And the docking mechanism is very simple. It's a conventional technology. It's a 5-point assembly, a 5-point locking mechanism, very similar to what you find in locomotives. It's got 5 points of locking. And it also based on there's a lot of sensor technology associated with it. The LuftCar, when I first considered it, I considered for the defense. I came from my last job was with the LuftCar as strategy working at a time. So I immediately thought of LuftCar as defense vehicle, and it ship to shore, doing landing into contested zones and with missions. Address future combat. Thank you. So the business case here is that we are trying to solve today's problem, right? We're not trying to build a vehicle for the future. Only 2% of the people travel or choose air travel for shorter distances because we don't have access to air travel in the first place. 28% of the United States does not have direct connection with air travel. They have to travel 1 or 2 hours to get to a commercial airport. But even otherwise, for shorter distances, we choose road transport because it's logistically convenient to wait in airports and once you go to a destination rather than the car. So I'm trying to solve both problems. So what if you take your car from point A to point B? It's not something new that I thought about. Dr. Braymont thought about it in mastermind professor. James Bond ran with the Golden, but that's my personal inspiration. So there is a big market. So if I do the docking mechanism, I buy get longer distances and I'll be competing with the cars. I'll be competing with the trucks. I'll be competing in a much larger market, and I am providing an opportunity to what we start for today. I don't want to do a replacement to air taxis for shuttle cars or Uber. I want to do a replacement to cars. So my market potential is going to be 2 times more than air taxi. So that's one of the reasons why I think the product hydrogen fuel cell would be a good fit there. I'm not coming across battery chemistry that that 300 miles distance. Again, our vision is to really preserve the freedom of travel, also serve distant communities, right? Whether it is delivering cargo to remote communities or delivering medical care, doing tourism, and even supporting long distance travel. I traveled to Orlando to Houston the other day with my Tesla. It took me 20 hours because I had 6 hours to my trip for charging. 6 hours. But with the vehicle with hydrogen refueling, the 10 minutes of fueling time, I would try twice the speed. I could get to Houston in like 6 hours with less, with not much of interruption. So that's our concept of operations. What you saw the video, We are licensed in NASA technology on flight propulsion. We are FAA appointed PMI that is supporting us. We are still not at the stage where we can actually say, but we are, we hope to see as we go towards that. We are partnered with 2 Florida universities, and we are in conversation with other states as well. We are putting together a very strong MOU in the region, the TDC, with Springfield Airport, the UDRI, and also ourselves, a few others, putting together a strong consortium of companies and supply chain. We develop our first prototypes in the region. We will also hope to demonstrate our first batch of rocket propellants. The vehicle is going to be autonomous, along with the hydrogen powered, so it's going to have distance perception, depth perception. The key is to for the vehicle to make its own decision of when to land. And the criteria is for my 17-year-old son to be able to land in safe locations without much of an hassle. So that the vehicle should be able to land on safe locations. We're approaching TRL3 right now. One of the challenges that we have is reducing the weight of the car module. The car module is going to have suspension, it's going to have wheels, it's going to have a platform. That's going to be the heaviest part of it. So our goal is to reduce that weight. More partner with supply chain to reduce. The overall vehicle for the most vehicle weight pounds. Payload capacity tells us about that. That's our team. I myself went to school in Ohio University. Make up part of my son will be there. For design is from Ohio State. There is a master's in architecture from Ohio State. We have a strong partner leadership team across the globe. Good business development team in Europe, Australia. That's big. Some people are part of the feature market cargo, last mile delivery, like I said, last mile delivery, we have LOI from insurance companies. We already have a purchase order for cargo. These customers coming and telling me about the different use cases that they tell them. Before yesterday, from US Navy, that said there are 10 different use cases. That's really delightful that we've now started an active conversation with this thing. Personal mode, we want to make a big comment about it. Our vehicle would connect small towns, rural communities with larger airports. So at night, we can operate our cars going into small cities, taking people from those cities to the large commercial airports that they don't have to drive all the way from here to Chicago to Florida commercial airports. Do all your biometrics, TSA check-in, and then go on board. So the hydrogen power will create a demand of up to $50 billion of hydrogen by 2030 in the United States, across the world. Based on the assumption that 20 to 40 kilograms of hydrogen will pack in this year, that will be range. Here the costs are around $2 per kilogram. I think you have a unique case, but unfortunately, as you know, we assigned 2 MOUs with airports in Germany, one to demonstrate the looks bad, another to actually demonstrate the use cases of commercial and private. We want to hope to do the same thing here in Ohio as well. They can be a big area and also the northeast. So this is the look bad concept that we released last year, so last week. We have what I'm showing you is 2 landing pads where these LuftCars can land, and they can move to these bays, what I call. The autonomous hydrogen refueling as the docking happens, and the road vehicles can depart and they can drive. Right. Our long-term business case is to make these 2 road modules and modules interchangeable. People can just rent the head modules, but they can own. So you can own a $35,000 and then you can go and dock it. Then the that module dock right from this place. Use that. Sometimes can where you have more efficiencies. So that way the market size is bigger that way, flexible. These are the hydrogen refueling ports as you show. The hydrogen refueling is strategically located along these hydrogen pathways, where the hydrogen that's being generated in the LuftCar or being imported elsewhere is going to be used for the aerial transportation, it will be also used for road transportation, and also that would be the long-term goal, but that has to work out with the energy markets. We are already part of two hydrogen communities, hydrogen hubs. One is the Southern Hydrogen Energy Association, which is in my state, Florida. Also part of the Oklahoma, Louisiana, Arkansas. This is the map that I generated in extensive discussion with myself yesterday from 11 to 11 p.m. Ohio Airways. These are the general air highways that I could think of, which connects the big cities. Gives more access to the Appalachian and to the industrial hubs within Ohio. So if you are going to put lift pads around it, every 50 miles you put a lift pad. The one big advantage with vehicles like lift cars and cars that run on hydrogen is that you don't need too many verticals. You don't need to tear down the existing infrastructure build for every few miles. We need probably one lift pad every radius, and that will fit in very nicely with the hydrogen plan for the state. So you can still use the existing infrastructure, existing workers. Like I said, we are one of the very few air and road vehicle concepts out there. We plan to be fully commercial with the autonomous version by 2026, but we will have a piloted version by 2025. All that assuming that certification happens in time. I'll talk a little bit about certification. We are trying to get our type certificate done by 2025, assuming we have a full-fledged prototype by 2024 time, right? 23. So probably do ourselves 3 years of certification. Airworthiness is something that we need to demonstrate by the time. Same thing with roadworthiness. We'll be working with NHTSA as well. We will continue those increased parallelly and autonomy by 2026. There are still a lot of details to figure out on hydrogen handling, safety codes and standards, and also on autonomy. But in the next few months, our focus will be very on understanding what it means to have autonomous vehicles, concept of operations. That's pretty much it. We are partnered with the industry. We are partnered with some universities. Also collaborations that we are working on. Any questions? We'll wait for the question. Thank you.
Thank you, Santh. Very, very cool concept, especially going into the hydrogen aspect of things. Our third speaker is John, and he's going to be talking a little bit different. We talked about big vehicles, more AAM vehicles. We're going to get back into the smaller ones, because that's a big part of what's going on in Ohio. So we're going to include that as part of it. It's part of 8 a.m. as well. So I'll turn it over to you, John.
Thank you, Jim. My name is John Graber. I'm the president of Workhorse's Aero organization. Workhorse is a Cincinnati-based company. I'm here with Diane Carrington, our VP of Operations. Okay. And Mike Curtis, our director of 135 operations. Diane's Air Force Academy C-17, C-141. Mike is Eastern, Pan Am, ATA, and he ran training at Southwest Airlines.
Correct.
No other good to say. You never want to fly the A model of anything, so I'm very happy to have a seasoned team. Zoe, I don't see Chris. Thank you all very much for your team and the work y'all have done. This has been great. I mean, it's really excellent. And We have openings for 107 drivers, mechanical engineers, electrical engineers, embedded systems engineers, aero engineers, manufacturing engineers, and I'm forgetting one. And software engineers.
It's a good thing you got our emails.
That's exactly right. Chris, while you were out, I was saying thank you very much. This is our business. Everything on that screen we make. That's our truck. Our vision is to pioneer the transition to electric vehicles. We have over 300 of those on the road. We just 8 million miles. That is a hybrid electric vehicle. We own a patent that's been issued to fly small UASs off of that truck. And we have those in service today in the very fall phase of that. That's our aircraft, which I'm going to spend a lot of time talking about. We've been working on it for over 5 years. We will spend millions of dollars this year on that effort. The guy on the left is our chief pilot. The guy on the right is our program manager. The guy on the right started as a co-op with us. Zoe and Chris, listen to me. Started as a co-op with us 5 years ago. He's the senior guy on our team. You can't make it up. That's true. He knows everything about what we do. And Alan Skipworth, our chief pilot, has been here 2 years. Okay. And since I'm talking about people, Joe Spangler, who I just met today, his son is one of our remote pilots in command who is coming home from Canada today, where he's been test flying all week, right? We're busy as busy can be, and we're looking for people all the time. So now I'll talk about certification and what we do. So we are based in Cincinnati. We have a manufacturing facility in Union City where we make our vehicles, and you can't do automotive engineering if you're not in Detroit. So we have a satellite engineering organization in Wixom. You can see the timeline here, what Justin was talking about. I joined Workhorse several years ago to help them work on this Surefly project. We ended up selling that to Moog. I know how to say it. And as a side gig, I get to still fly that aircraft. Yeah. So I've been flying it since 2017, and we're building time on it all the time. But I work full time for Workhorse, trying to figure out small UAS. Our vision, as I said, is to transition to zero emission commercial vehicles. We believe that's the most virtuous use of our technology. How we do it's on the top of the slide. How we do it's on the bottom of the slide. What we do is how we think about it on the top. So certification, why? This is our aircraft. It's 33 pounds. It's 22 pounds with a 10-pound cargo, so it will carry about 10 pounds for 10 miles. The very first thing on that list is safe. We're talking a lot today about community acceptance. If we get this wrong, if we're not safe and reliable, none of the rest of it matters. I'm glad Mike's here to talk about certification, but we need to do that whether the FAA is in the room or not, right? Full stop. If one of our aircraft flies over your house and crashes into the school bus full of nuns that's driving by in your front street, you know that we won't fly anymore, right? So we think about our mission as being safe, reliable. Then we'll fly 10 pounds for 10 miles. We have a winch that we are patenting. We have 30 patents in the works. Cameras that we'll carry are LiDAR. And then we integrate with a truck. So when you think about all the hard things to do, the LuftCar piece that pitched today, you are the only guy I've heard of who is dumber than we are. You are doing everything hard there is to do. What we're doing is hard, and we know it's hard. It's amazing to see. I want you to win, brother. You do. I mean, you think about this stuff. Autonomous, electric, Part 2117B, new and novel. FAA has never done it before. We're leading each other by the hand. It's just amazing how hard this is. Since Christmas, we've lost about 25 flight days Snow, okay, makes sense. Wind, all right, makes sense. Rain, okay, I got that. Solar flares, okay, we've lost flight time to solar flares, right? And so we get up early in the morning to make up time, and we're working 7 days a week because we're in a hurry. Fall. It's like the 4 horsemen of the apocalypse or something. We just can't get out of our own way sometimes. We've got to fly. And we're not volcano. So what we're after is enabling point-to-point. When you think about what FedEx did 45 years ago, it was established time-definite delivery. When it has to, positively, absolutely has to be there overnight. Amazon Prime, 2-day delivery is fine. Walmart now, sub 10 minutes from the click on the mouse to the olive oil showing up in your front yard. That's what you have to believe in our business model. Chris, Zoe, that's why you need to think about us. We believe in it. And if you think about what that means, my son, who's 23, and he thinks about this all the time, you think about, how do I get a car off the road? How do I have less congestion? How do I have a lower carbon footprint? What would that lower carbon footprint look like? And we sell 11,000 foot package delivery trucks. If you could sell fewer of those and match the power expended to the power required, and only that, to move your package in our aircraft, we all win. It's worth doing. It's absolutely worth doing. It ain't easy, and it's going to be really, really difficult to figure out all the nuances, but we think it's really important. So we entered the 2117 process in 2020. We're working with the Los Angeles ACO. We're working with the Vandalia right down the street in Idaho. And give you an example of how the FAA can do things. On a recent Thursday, we gave them our quality manual for review. The following Tuesday, we got it back with comments, and they didn't work on Friday. Thursday, Monday, Tuesday, we got it back. And if you happen to be in that sphere and you ever work with those guys, the guy we work with is a guy named David Jeffrey, and he hung the moon. He's amazing. The feds can do that right if they want to. I've been involved with feds for a long time, and you tease him, Mike is a good fed, but he's a fed. It can work. It can absolutely work. We're in the Ohio Smart 33 corridor. We're flying. Tim got us involved in that. Thank you very much. We're going to be flying next month. We're in North Dakota, Northern Plains. We're a signatory up there. We'll be flying there May or June. May. We're going to be flying there in May as well. We have a government contract to LiDAR surveying for wetlands in a southern state we're working on. And we have a parachute recovery system that's ASTM certified. And I'm particularly proud of that because we did not understand how that was all going to lay out. And when you go do that, you have to fly 45 deployments. We flew 46 and we passed. And one extra we flew was because we didn't quite understand the test. So we really did it in 45 out of 45. And what's exceptional about that is that when we did it, we took 5 aircraft there, right? So we could beat the snot out of them. So we took 5 aircraft out there. We only used 3 because they work. They're just horses. They just work really, really well. So in certification, I'll tell you, it is really hard. I use that joke, but it's true. You don't want to be the A model if you can figure it out. Be the C or D model. I'm delighted that Google and Amazon and Matternet and those guys are in the first tranche because I can't imagine what it must be like to be figuring that out together. The neat thing about Mike Romanowski is I'll tell you, he is trying to figure it out with us together. And it ain't easy, and it ain't for the faint of heart, but we will figure it out. There's just no doubt about it. So those are my comments. Thank you very much. Still leave me alone. I'm going to give him my cards right after.
I think you could tie him up and take it back.
Probably a law against that.
All right, last but not least, our FAA representative, Dr. Michael Romanowski, is going to go tell us all the good reasons why we are going to do this.
Jim. Christopher, Zoe, thank you so much. I tell you, this panel already has been a lot of fun. And I think what we're going to talk about here in the follow-on discussion, it highlights not only the challenges, but some real path forward. Lynn, Christopher, your lunchtime remarks, when you talk about all the technologies that you're working on here at the university, and then we heard Bob Pierce talk about all the technologies and the concepts they're working on at NASA. We're seeing all those real time every day in the FAA, and we're working on the pathway to certify every one of those. And it's showing us the remarkable capabilities that are going to come to the market. I've got absolutely no doubt that we are going to see phenomenal change, phenomenal progress as a society over the next several years, decade, and beyond. I got to tell you that this forum, state leaders, university leaders, community leaders, industry leaders, and most of all, makes a special case having so many students in the group as well. I go back to my days when I came out of college. I was went to college in the early 80s, came into the workforce in the mid 80s. And aviation, aerospace was booming then. But I always felt like I was missing the golden age. I missed the golden age of aviation. And that I was catching the tail end of it. I'm going to tell you right now, I feel like I'm in the new golden age of aviation. And the opportunities that all of you folks entering the workforce are going to have in the coming years, just astounding. I personally feel like a kid in the candy store with the work that they're doing every day, working to see these capabilities come to fruition. I truly believe they're going to deliver real, substantial safety improvements as well as societal benefits. And our framework, obviously, in the FAA is that safety goal, not just insurance safety, but when we look at the capabilities and materials that we're seeing, production techniques that we're seeing, software, automation, electrification, environmental improvements, not to mention whole new modes of delivery of services. We just heard a whole range on this panel already. Plus, we're dealing with low boom, high environmental friendly supersonic aircraft, and other sorts of things. We are going to see some basic things. So, and that's our job right now as a regulator is to figure out the way to meet society's expectations for safety. As we work to integrate those into the communities, as we work to help the companies work to solidify the business case. Our job is to ensure the safety meets public expectations of safety. And one of the things that is unfortunate for, particularly on the certification, is we do have a certification framework that is flexible enough to handle the wide range of concepts we've heard on this panel today, and then everything else that we're seeing. And there's a statement in the industry that folks who've been around airports know this one well, or if you've seen one airport, you've seen one airport, because they're also just dramatically different. Well, I think what we saw on this panel today is if you've seen one new emerging aircraft project, you've seen one new emerging aircraft project. They're all so different. And so while there may be thoughts about, well, we just need the universal path to certify new technology. As the regulator, I'm incredibly afraid that if we went out and imposed a unified certification path for new technologies and vehicle concepts, we are going to stifle the innovation that we're seeing in the marketplace. Instead, what we want to do is take advantage of that full flexibility that we have today, understand the safety targets that we have for small airplanes, and work within our framework to find the right solution for that one. As John said, it's not necessarily easy, but what we're also seeing is what we heard that we find this pathway. So what we are able to do is we are looking at the performance-based rewrite of small airplane regulations. What that means is instead of having prescriptive design features, we lay out the safety objectives in flight controls, in structures, in all the systems, subsystems. We're very clear on the safety objectives. Then we let the innovation occur how to achieve them. You can use classical methods, or you can use voluntary consensus standards like the ASTM standards, the SAE standards, or you can use something that the company developed on its own as a way to demonstrate that safety performance. The same thing, helicopters, the helicopter rules don't work. You're not a helicopter. Well, we can look to where those helicopters make sense, where we're bringing certification is, where the airplane rules make sense, or where we just need to craft something entirely new. That's safety challenge. We've done this. So we're not taking that one size fits all. And John was alluding to the small UAS side as well. What we've done with that is we've done a lot of work. What is an appropriate framework? What part of that vehicle in the system should we actually be certified? Because I don't know how many of you know this, but this is a UAS control station in many cases. I don't think you want the FAA certified, right? But we do need to know it delivers the safety, right? We don't need to be sending these to FAA approved repair stations for maintenance. We do need to know that it works, right? So we're working on some innovative ways to make sure that that happens while we look at the vehicle, make sure it meets these safety objectives. And we've come up with a framework there that kind of goes back to the old school. Durability and reliability. Take your vehicle, look at all the piece parts and components, go fly the vehicle, demonstrate the durability, show that it works when you have known failures. Have some design features like if you have fuel on board, it's not going to protect you against ground fires if it comes down. We have ways to protect people working in and around those aircraft. So that we've actually published now 10 final certification requirements for 10 different programs. So the method works. It's not necessarily easy as you highlighted, but it's something that is seeing the advancements in. So it works for the aircraft as a whole, but also we're looking at how we do this for the technologies, the systems that underpin advanced flight controls. I talked earlier about some of the new production techniques, the trend towards autonomy, making sure that we're able to address that as well. One of the things that's been instrumental in us being able to engage the industry and come up with the solutions for the programs is back in 2018, we launched something in my organization called the Center for Emerging Concepts in Aviation. I call it the Innovation Center. It's easier for me to say. You'll hear people call it CC. So the Innovation Center, what we're doing is it's in effect an open house for any applicant has that good idea and wants to understand how do they in fact move forward on that path to certification. There are some that are more on such a much more solidified. It's here's what you're going to need to do, here's the time frames, here's roughly what the ideas you're going to need to come to grips with, or you're going to need to understand in terms of where that safety bar is. And then we also advanced into very hardcore, these are going to be the certification requirements. And again, it's not it's all these technologies and concepts that we're seeing. So right now, we've probably got, depending on how you want to count it, but in hardcore certification planning, we're about a dozen, maybe more advanced air mobility. We've got 30 to 40 unmanned aircraft, smaller UAS and larger UAS. We've got about a dozen electric propulsion projects. And by the way, we're able to certify electric propulsion as a standalone under the framework, or we're able to certify it as part of the integrated. We've got hybrid electric propulsion, and we've got hydrogen fuel cell propulsion, both for new applications and retrofit applications. So those types of things. About 70 projects overall that are in that hardcore certification development. And I've got to tell you, it's rewarding to see a few people with an idea come in, and a few years later see that those same companies now have hundreds of people building factories, they're building infrastructure, they're laying out the deposit vaults, they're building products and vehicles in these new factories. It's amazing. So that gives us the overview. So as a regular, to look at all the cross-cutting issues, understand what's coming our way, where we may need to do additional research as an agency, where we need to leverage NASA's research as an agency, that's a strategic thrust of ours, where we need to develop and where our path with developing regulations and policies, where new consensus standards are formed, and start feeding those in a much more strategic, proactive approach. So again, it's been extremely successful, and I think by the fact we're seeing such a reception from the industry that highlights. I'm going to shift gears as I close my remarks. John, I'm going to one up you. I'll take the resumes too. We are hiring. And I'd be remiss where we're in an audience with, I would imagine, a number of graduating students to not call out. There's an address there, and there's a subject line. If you send your resume materials to Jessica Legler, we have the ability to do some streamlined hiring. And frankly, that goes for any engineer, scientist, aviation professional. But I want to make that special call to the students here. And so Zoe will have that. She's got these briefings, so if anyone doesn't write it down, take advantage. All these technologies, all these things that we're talking about, we're hiring subject matter experts in those areas, or folks who want to become subject matter experts in those areas. Engineering, manufacturing. So data scientists, that's something they're focused on. That's something that we're looking at. So before we follow on discussions, I look forward to the rest of this panel and the networking beyond. Thank you.
Okay, so we had this a couple of times. Who all here is a student? Raise your hand. Everybody got your eyes on those hands. I don't think any of you are walking out of here without a letter. If you didn't already have it. All right, so we did get a little bit of a late start, so I am been told I'm allowed to run over a break session. So I assume that just means you're delaying the break and everything is shit. So I'll try to pull it back in a little bit, but we're going to take we have two questions that came in over the tool there. Then, so I'm going to go ahead and start with those and not direct them anywhere particular. So The first one is, what level of testing do communication systems undergo in eVTOL certifications? Are new radio architectures being tested for future air traffic management scenarios? And are tests utilizing traditional air mobile systems and air traffic control? Kind of a rambling question. I think what it comes down to is avionics communication part.
Maybe I'll start there and,
Yeah.
and others can join in. There, as you said, there's multi parts to this. One of the things I did in past life was I was responsible for the FAA's efforts on what we call the next generation air transportation system, or next gen, and all the integration of the modernization of air traffic control architecture. We've been doing for the past decade plus hardcore modernization that involves upgrades in the communication infrastructure. It involves the deployment of data communications infrastructure so that the communications between an aircraft and the air traffic controllers can be streamlined through the use of electronic data message versus voice communications. Because voice communications, when you get down to it, is pretty inefficient in terms of its ability to manage. So we've been deploying that. Now, shifting into this space, most of the communications in the advanced air mobility aircraft are more or less conventional. You know, the radio communications between the aircraft and the ground and the like. There's a lot of data telemetry that's being built into the aircraft that will be for company use and the like. And maybe some of the guys can comment on that, but that's not actually the infrastructure side. What is interesting though is on the small unmanned aircraft side is you are seeing a wide variety of come into play. Most of it not using air traffic infrastructure, but using various company means or cell-based means to communicate between the aircraft and its control stations. So we're not prescriptive in that area. What we are looking for is, number one, the effectiveness of the communications, both between where the control or dispatch area center is and the folks operating or monitoring remote operations, as well as with the vehicle and back. We're looking at the effectiveness of those communications, because a lot of that is based on web-based services as well. And that's something we don't necessarily want to get into regulating. So we do want to take advantage of. The other, and then we also are very keen on what happens when it doesn't work, right? And when we talked about the durability and reliability framework, how does the vehicle behave when it loses signal? So what we're really doing right now is we're just asking for the specifications and the interfaces in those areas. We're not actually prescribing what those have to be. So just like the question was a little rambly, I was a little rambly in the answer, but there's such a wide range of that.
It's a perfect kind of answer for that question. Just in the or you're doing how you're working.
Sure, yeah, I'll say a little something. As far as our communications, and this is a vehicle certification panel, I don't know if we'll be certifying this, but it's something I didn't get to in my presentation, but is that we're utilizing small UAS, scale UAS in our flight testing, right? We have agile development for our software flight controls. We test that out on a small drone, roll it out to the larger prototype. So with that, we take advantage of, for us, it's LTE, remote diagnostics and telemetry. So not only do we get live stream telemetry, but we can also do fly-by-mouse with our scale drones. With that, we will be testing that on our larger platform unmanned configuration. But again, the path to those sorts of communications for larger vehicles, we think are a little ways out. Definitely for the smaller scale vehicles, I think that's much closer. There's a much more kind of defined path. But it's something that we definitely utilize in our testing at the moment. when it makes sense to roll it out to the larger vehicle and certifications we want.
It's, what I tell you is it's surprising how complicated this is, how hard it is to solve. We think, as I said, 10-mile range. So typically with a 10-pound package, 5 miles out, if we can't deliver it, we need to fly 5 miles back. Pre-flight planning manages all the normals, non-normals, airspace requirements of that, frequency requirements of that. We use LTE, just like Justin talks about, and we spend most of our time talking about I'm looking at Diane because she's going to nod her head or shake her head. Primary, alternate, and enunciation of degraded states, and how we can flip-flop between primary and alternate, and what a degraded state results in. We haven't put our weight down yet on anything besides LTE. We're still testing, right? Okay. So we're still trying to understand what the secondary is. Because it's got to be something that can go over the horizon. So we talk about things like a tethered station, that kind of thing. We've flown for one of the large cell phone providers to help them understand how LTE works in flight. And it's fascinating. Cell towers point down, not up. We're only 400 AGL and below, right? You think, who cares? How bad can that be? It can be bad. And then the other thing that's really interesting is when you're flying 100, 150 AGL, whatever that number is, instead of 1 or 2 cell towers, you can pick up 19 or 20. And the cell phone providers hate that because you're soaking up their resource, right? So you got to figure all that out. And we're not in a final place yet.
Challenges indeed. Not what we would expect to hear from a certification panel, right? Oh, the last thing I wanted to get to, which is not actually on the list of questions that came up with, as we have progressed into this 21st century, we've gotten used to these things in our pocket, right? Getting upgraded every 2-3 years, right? From technology and software, and for a lot of people even hardware, sometimes a little earlier than that. It seems to me that these vehicles are ripe for continuous software updates and likely hardware updates as prop rotors, propellers, lift props all get redesigned, upgraded, we get better materials. How does a technology improvement plan factor into your certification plans? Or does it? We'll start with Santh first, and then we'll end with my whole.
Yeah, well, fortunately, I have some service experience from GE and Siemens, where we used to do condition-based maintenance. So many of us rotating parts. I'm planning to do a similar kind of MRO schedule for our business. That all the rotating parts will be maintained, will be observed continuously, prepared, replaced every 6 months. I don't know the exact numbers yet. And then looking at high temperature components, including hydrogen fuel cell and fuel dispensation, things like that, and batteries, and do a maintenance procedure on that or something like that. So we'll do come up with a service model where there'll be an opportunity to do modifications and upgrades. So we were still working on it, but we have a very good idea of what we want to do.
Sure, I'll bet. So I talked a little bit about Moog Core. We're a big company, 12,000 people worldwide. The core does a lot of things really well. They've got processes that are reliable, but they're rigid. So us on the growth and innovation team, we're a bit of a startup vibe in a big company. And we are also not only innovating in vehicles, in systems, but also in processes. So we have a 2-week agile sprint for our flight control software, which is also model-based environment and written requirements all together, along with a 2-week software verification sprint. So that works really well for us to turn around issues in our flight control software. We can have it fixed and verified, flight tested on a small scale platform within a month, which is pretty fast for us. And we whether it stays with 2 week sprints or there's some other number of weeks that makes sense. But as we go forward and get the platform through certification, it's just a great way to get problems fixed and to really keep innovation going.
I would tell you, we spend a lot of time thinking about residual values and how the economic proposition works in a broader marketplace. Our aircraft has 1,284 parts on it, not line items, but parts, individual parts, only 1,284. Of that 1,284 parts, roughly 100 are parts we make. Most of them, motors, ESCs, batteries, things like that. We go to the market and buy, and they will last X amount of time. If we do our job right, we have instructions for continued airworthiness out there so that they never fail on the aircraft. Take hardware out of that equation entirely. Then it comes down to software and optimization. We believe that, like the cell phone example Mike talked about, we believe we can push that kind of stuff over the air as required. There's a Boeing model for that. There's an Airbus model for that. There's a certification model for that we will follow. But by and large, when we field the slant A, B, or C model, it's going to produce a weight for an endurance, for a set of atmospherics, and we'll maintain it to keep that. The software piece will change as required for safety and reliability issues. But if we get this right, we won't do much on the hardware side.
Dr. Romanowski, I think you have 1 minute.
Sure, 1 minute, okay. So I think the guys have outlined a number of the things that we look at and we work with the companies on. We've been fortunate and we have a number of approved commercial operators under Part 135 now with small areas that we've been able to work through a lot of the logistics of change management and how that's demonstrated on the operational side, on the current infrastructure side, on the software side. We've also looked at, as we've been doing the certification of the aircraft in small units, how are we going to handle commercial parts in that certification and the production? We put in some policies for doing that. Nevertheless, we've also been working with the companies on what are the change management frameworks in terms of major changes, minor changes, and how we work through those things where we can take similarity and analysis where we might need additional testing, those sorts of things. But ultimately, when it gets down to the vehicles with people on board, it's really going to come down to is looking at the safety criticality of the changes and making sure that they do meet that safety objective. If you're making significant changes like some you talked about, yeah, that's new substantiation, just like it is in conventional aviation. But again, if it's planned properly, that works out. And we're also looking at how are we going to be doing models and all this sort of amendments and all that sort of thing. So it's a continuum of how you handle it based on safety criticality, the public expectation, and need for safety. But there are methods.
Thank you, panelists. Thank you, audience.
Buckeye Vertical, John.Graber at Workhorse.com.
Really quick, I guess I'll follow up and ask a question of my own. So John and Michael, which one of you pays more? Thank you all for taking time to show us the complexities and realities of the certification process. You reminded us that this industry's progress must be matched with equal enthusiasm and advancements on the regulatory side. I found it especially insightful to listen to the FAA speak on the support that they'd like to provide to some of the OEMs. And while it might often seem that you're being held back, you're also being held accountable. And I think that's something that we can all appreciate.